The effect of L by D ratio on misalignment can be understood from the following diagram. Here we have a journal of diameter D and a sleeve of length L, and there is a certain amount of clearance. Now typically here we are looking at L by D ratio, and I would call this L by D ratio slightly greater than 1. So this is a large L by D ratio. What happens in the misaligned condition if we consider this axis of the journal, and if there is a slight misalignment about this axis, this journal tends to very easily rub against the sleeve at the edges. So the area where the contact and the friction may happen is at these edges. So when we have a very large L by D ratio, which is probably greater than 1, we find that the bearing becomes very sensitive to misalignments. Even a small misalignment in this direction will cause contact between the journal and the sleeve edges at the following points, and also at these following points. On the other hand, if we have a very small L by D ratio, which is seen by a small bearing of this sort, the amount of misalignment required before contact happens between the journal and the sleeve is larger. So therefore we see that when L by D is less than 1, the bearing has more tolerance to misalignment. So here from this diagram we can see that the large L by D ratio has a very high sensitivity to misalignment. That means a very small amount of misalignment will cause the bearing failure. However, a value of L by D less than 1, that is a small L by D ratio, does not have that much sensitivity. That means even if the misalignment is slightly larger, there will not be contact between the journal and the sleeve. So this is the effect of misalignment on L by D ratio on misalignment. Thank you.